Good morning. I'm here talking with Aadel Chaudhuri, who is an assistant professor of radiology at Washington University School of Medicine in St. Louis. Um, Dr. Chaudhuri is also a 2018 Young Investigator with the Cancer Research Foundation. And I'm so excited to talk to you. This is our start to internet-based phone calls. So thank you for being with me.
You're very welcome. Thank you.
So first of all, can you give us a quick précis of what you were working on or have been working on your Young Investigator Award work?
Yeah, of course, of course. So my lab focuses on liquid biopsies, and we specifically focus on cell-free DNA and analyzing cell-free DNA in order to measure responses to
Mm-hmm.
therapy for patients with solid tumor malignancies. Um, in my postdoctoral work, I worked on non-small cell lung cancer and showed that ctDNA analysis could measure molecular residual disease after treatment quite robustly.
Okay.
To the point that if you measured molecular residual disease, those patients recur. And
Uh-huh.
when you can't measure it, those patients remain disease-free. And that was with a highly sensitive technology called CAP-seq. So we're now applying these types of technologies to other malignancies, such as small cell lung cancer, such as colorectal cancer. Um, and what we're seeing is we're seeing similar patterns. We're seeing that we can measure molecular residual disease in these
Mm-hmm.
malignancies, and that correlates strongly with their outcomes. Um, Currently, I mean, the research is going pretty well. We're putting together some of our research for publication currently, focusing on colorectal cancer. We just had a study that's not directly funded by Cancer Research Foundation, but we had a paper just come out in prostate cancer.
Yes.
I'd say overall, everything that you guys have been supporting has been going pretty well.
Wonderful. So is it using this generally to figure out how to treat people or also to actually identify disease beforehand?
So it's a combination of both. So I mean, the idea being that when we see disease on an imaging study, we do something about it.
Mm-hmm.
We say that, okay, you still have disease left, it hasn't been completely taken care of, let's do something about it. Let's treat it with
Okay.
radiation, let's cut it out, let's give
Right.
you more chemotherapy. Now we're dealing with disease that we can't necessarily see. It's
Uh-huh.
not showing up on imaging, it's not showing up on our routine studies, it's truly molecular residual disease.
Okay.
And so we and others are asking the question that if we see it at that early juncture,
Mm-hmm.
can we take care of it? And
Right.
theoretically, that should be the best stage where you're taking care of it. It's so small, you can't even see it. It's just a
Got it.
matter of cells. And those
Uh-huh.
cells could be, if you do the right thing, you could just get rid of them
Mm-hmm.
at a point where you have such a small population.
Do you think that the technology you're using will actually allow you to identify them as targets as well as indicators,
Yeah, I mean, so
ideally?
we're doing oncogenomic profiling as well. So
Uh-huh.
we can measure what sort of genomic alterations they have. Are those actionable alterations? Could they be amenable to targeted therapies? So the hope is yes. And
Okay.
we've been a part of studies that have really taken us in that direction,
Mm-hmm.
where we can detect molecular residual disease and then do something about it.
Okay.
Treat with immune checkpoint blockade, for example, in order to address whatever residual disease is left after lung cancer treatment.